Good vibes, mathletes. This time, we're going to answer the last part of your week 3 worksheet on illustrating rational algebraic expressions. Okay, and that's letter D. Represent the given phrases and statements into rational algebraic expressions. Okay, so one of the method here that will help you represent the verbal phrase into mathematical statement is to work backwards. Okay, so sometimes or more often we have to work backwards. We have to start from the last on the last part of the sentence and then going back. For example, in number 1, the quotient of 5 less than thrice a number and twice the sum of a number 2. Okay, if we're going to read the whole statement outright, it's quite confusing. Where are we going to um, start writing our mathematical statement, right? But if we're going to start at the end of the sentence, okay, for instance, number and 2, automatically, if it is not stated what variable is the number represented, actually we can represent it, we can choose any variable from the alphabets, but usually we use x. Okay, so let's say the number here is x. This is x. So number and 2. So what are we supposed to do with the number and 2? It is says it said it says that we're going to get the sum, right? Sum of a number x and 2. That means we are going to add x and 2. Okay? And going further backward, next is twice. Why do we say twice? That means 2. Okay? So twice the sum. So the sum of x plus 2. That means we have 2 times the sum of the number a number x and 2. So that means we have 2 times the quantity x plus 2. Then going further, we have thrice a number. Again, represent this by x, and then thrice a number, that means 3. So that means 3x, and then 5 less than. Okay, so 5 less than. So we should be very careful when dealing with this kind of verbal phrase in mathematics. 5 less than. That means we are going to um, put this statement at the end of thrice. For example, thrice a number. That means thrice a number minus 5. So it is read as 5 less than thrice a number x. Supposing we have 7 less than thrice a number. That means 3x minus 7. Okay, let's say 3 more than thrice a number. that means 3x. More than means plus. Okay? More than means plus. Okay? So, twice, more than, thrice a number. Okay? So, we have 3x plus 2. So, remember, less than is subtraction. Okay? Less than is subtraction. More than is addition. And remember the verbal phrase 5 less than, it should be put, okay, at the end of the statement thrice a number. Okay? It should not be written as 5 minus 3x. Understood? This is different. Okay? So we read this one actually as 5 minus thrice a number, and not 5 less than thrice a number. Okay? Hopefully that's clear. Let's erase this. So again, so number x, and then 2, and then twice the sum of a number x and 2. So we have 2 times the quantity x plus 2, and thrice a number, if this is x and we have thrice here, so we have 3x, and then 5 less than, so we have 3x minus 5. And we have another one here, quotient. When we say quotient, that is division. Okay? It is always in the form of P over Q. So that means P here is 5 less than thrice a number. That means we have 3x minus 5. And the next is twice the sum of a number and 2. That will be our denominator. So we have 2 times the quantity x plus 2. So this is actually the expression representing, or the rational expression to be exact, representing the verbal phrase, the quotient of 5 less than thrice a number and twice the sum of a number and 2. Okay? If you have any question, you may comment actually. I'm going to upload this on YouTube, on my channel. Then if you have any comment or clarification, just comment it down, and then I'm going to answer it. After which, then let's have number 2. In number 2, we have the denominator of a certain fraction is 3 times the numerator. If 2 is added to the numerator and subtracted from the denominator, write the expression. Okay, again, statements like this, or verbal phrase like this, we have to start, or we have to use the method working backwards. So 3 times the first mathematical statement here is 3 times the numerator, or 3 times the numerator. Since it wasn't mentioned what variable actually the numerator is, so we have to represent this in terms of variable. You can use n as numerator. You can use x. Okay, it doesn't matter. But usually we use the first, since we are talking about numerator, we can use n to represent numerator. Okay, or x. So that depends on you. So let's say we have n here for numerator. So it is described that the numerator is 3 times the numerator, I mean. So 3 times the numerator. So we have 3 here. So that means 3n. Okay? So that means 3n. And the denominator was described in terms of the numerator. It says that the denominator of a certain fraction is 3 times the numerator. Okay? So that means if the numerator is n, so the denominator is 3n, right? So 3 times the numerator. The denominator is 3 times the denominator. And then the next paragraph, if 2 is added to the numerator, so that means we're going to add 2, sorry, so plus 2, and subtracted from the denominator, so x minus 2. Write the expression. So presto, we have this one. So n plus 2 all over 3n minus 2. So that's for number 2. Then for number 3. So Julius can paint a house 3 times faster than Ruben or Ruben. What part of the work can be completed if Julius works alone? So this is actually a work-related problem. Okay, in this case, we need to determine first the rate of work, okay, of each worker. Okay, so let's start from the first paragraph. Julius can paint a house 3 times faster than Ruben. So it wasn't mentioned actually if what variable is represented in terms of the rate of work of Ruben. Okay, so in this case we're going to represent the rate of work of, or how fast Ruben work is R. Okay, since it starts with letter R. Okay, R. Then it says that Julius can paint a house 3 times faster than Ruben. If Ruben can finish painting the house in R minutes, for example, R hours or R days, then Julius can finish the task 3 times faster than Ruben. That means the rate of work, or Julius' rate of work, is 3R, right? 3 times faster than Ruben. 3R. However, we're talking about rate of work. So this is only the number of hours. This R actually represents the number of hours Ruben can paint a house, and Julius can do the same job 3 times faster than Ruben. So we have 3R. And if we're going to express this as rate of work, so we get the reciprocal actually. We always based it on, if you're talking about minutes, so 1 minute, based on 1 minute, for example. If you're talking about 1 hour, so based on 1 hour. And then if you are talking about days, then based on 1 day. Okay. Supposing that, or assuming rather that they haven't worked yet for how many hours. Okay. So rate of work is 1 over R. So that means in 1 hour, Julius' rate of work is 3R. So 1 over 3R. While Ruben is, so this is Julius, while Ruben is 1 over R. Okay, but we are talking about Julius' work. Okay, Julius rate of work. So therefore, the answer is 1 over 3R. Okay, so that's it for our week 3 worksheet on illustrating rational algebraic expressions. So you have to take note the difference between equation and expression. So an expression does not contain an inequality symbol. So it is just merely an expression. But when we say equation, it involves the equality symbol or the equal sign. Okay? So that's all for our week 3 worksheets, and stay safe and have a good day.